There are three main forms of quadratic equations. The most common one is standard form, which is y equals ax squared plus bx plus c. The sign of a in this form determines the direction of the quadratic. If a is positive, the quadratic opens upward, like a smiley face. If a is negative, the quadratic faces downward, like a frown. Ideally, a is 1, but if a is, say, a fraction, like 1/2, the quadratic will be much wider than normal. If a is greater than 1, like say 3 for example, the quadratic will look skinnier. C is the y-intercept, so where the parabola intersects the y-axis. The best way to find the vertex of a quadratic in this form is by using the formula -b/2a. This will give you the x value of the vertex. You would then have to plug that back into your equation and solve for the y value. To find the solutions of a quadratic, which means where the graph intersects the x-axis, you could do two things. You can factor or use the quadratic formula. Most of the time, quadratics can be solved by factoring, so be sure to look for that first before jumping straight into the long and tedious quadratic formula. Solutions to a quadratic can also be called zeros or roots, but they all mean the same thing. Exams like the SAT and ACT are notorious for asking you to find the sum of solutions or product of solutions for a quadratic. The good thing is, this requires very little work if you know the trick. Let's look at this question. It says find the sum of solutions for the quadratic 4x squared plus 16x minus 5. Now, this question makes you feel like you have to find the two solutions and then add them up to get your answer, whether it be by factoring or using the quadratic formula. But for any quadratic in standard form, the sum of solutions is simply -b/a. In our case, b is 16, and a is 4, so we do -16 divided by 4, which gives us -4 as our answer. Let's try another one. Find the product of solutions to the quadratic 4x squared plus 16x minus 5. Now, before you leap into factoring this or plugging it into the formula, there is thankfully a trick for this too. For any quadratic in standard form, the product of solutions is c/a. Our c in this case is -5. Be sure you include the sign that comes before the number when doing this trick. And our a is 4. Therefore our answer is -5/4. The intercept form of a quadratic is one of the nicer forms, because it makes it easy to find the roots. This form already does the factoring for you. All you have to do is set each group equal to 0 and solve for x. We do this because our solutions, or roots of a quadratic, occur when the parabola intersects the x-axis, which is also when y equals 0. Let's look at an example. What are the zeros of the quadratic equation y equals x plus 3 times x minus 2? When we set x plus 3 equal to 0 and x minus 2 equal to 0 and then solve for x, we end up with the solutions -3 and +2. But when you have equations like this where the coefficient of x is just 1, you don't have to constantly set them equal to 0 and solve. A simple trick to remember is that the actual solutions will be the opposite of what they look like. In this equation, it looks like the answer should be +3 and -2, so the actual solutions, or zeros of the quadratic, would be the opposite, giving us -3 and +2. Another important thing to remember is that the vertex is always perfectly in between your two roots. The actual point will be either above or below the midpoint between one root and the other root. You might be thinking, I don't know the midpoint formula. Well, there's a trick for that too. The midpoint is simply the average of your 2 points. So instead of having to use the formula -b/2a, you can simply take the average of your two roots, and this will give you the x value of your vertex. So in this case, since our roots are at -3 and +2, we simply add these two numbers up. This gives us -1. We then divide by 2 since we're taking the average of two numbers to find the midpoint. This gives us -1/2. So the x value of the vertex is -1/2. This is also called the axis of symmetry. To get the y value of the vertex, all you have to do is just plug in -1/2 into the equation and solve for y. So this little trick allows you to quickly find the vertex and axis of symmetry for any quadratic expressed in intercept form. Let's take a look at the following problem. Find the solutions to the quadratic equation y equals x squared plus 6x plus 8. The first thing when answering questions like these is to look at the solutions because they give you a hint as to how to approach the question. All our answer choices are nice, clean whole numbers, which means that we should be able to easily factor it out without having to use the quadratic formula. If you see answer choices with the radicals or anything like that, then you use the quadratic formula. So how do we factor this? First, we look at the coefficient of x squared, which is also called the a in standard form. If a is just 1, all we have to do is think of two numbers that multiply to give us c, which in this case is 8, and add up to give us b, which is 6. Let's try 8 and 1. They multiply to give us 8, but there's no way of adding them up to get 6, even if you make one negative and one positive. So let's try another combination. How about +4 and +2? 4 times 2 gives us 8, and 4 plus 2 gives us 6. Since this combination works, we can write down +4 and +2 like so. The next step is to put them in a form called intercept form, which for a quadratic like this will always be two parentheses groups and one x in each, like so. The last step is finding the solutions, which is simply the opposite of what x appears to be. It looks like the answer would be +4 and +2, so the actual solutions to the quadratic will be x equals -4 and -2. Let's take a look at another one. Find the zeros of the quadratic equation y equals 3x squared plus 9x minus 12. The first step whenever you see a question where the a is not equal to 1 is see if you can scale it down by a common factor. If you look closely, you'll notice that all three terms are just multiples of 3. This means that we can factor out a 3 from each term. So if we pull out the 3, we'll be left with 3 times x squared plus 3x minus 4. Since 3 divided by 3 is 1, 9 divided by 3 is 3, and -12 divided by 3 is -4. The good thing about scaling down a quadratic is that it doesn't change the roots, which is often what we're trying to find. Now, because we're multiplying by 3, the graph will be stretched out, but our solutions will always remain the same, which means we can ignore the 3 and simply solve the inner quadratic by factoring, since both of them are going to have the same solutions. Now let's think of some combinations of numbers. +4 and -1 multiply to give us -4 and add to give us 3, so our intercept form will look like this. And the solutions, which are also called zeros, will be x equals -4 and x equals +1. A could also be negative like in this example. When solving quadratics by factoring, our a should always be positive to make things easy. So to get rid of that negative, we can factor it out of every term by simply switching their signs. This gives us the equation y equals -1 times x squared plus 2x minus 3. Whenever we have a scalar, be it a simple negative like in this problem, or a 3 in the previous problem, as long as it's just a constant number, the inner quadratic will always have the same roots as our original equation. So all we have to do is find the solutions to x squared plus 2x minus 3. This simplifies to x plus 3 and x minus 1. So our solutions will be x equals negative 3 and x equals positive 1. But what if our quadratic doesn't have a common factor that we can use to scale it down? Then we'll have to use an approach called the crisscross method. Let's look at an example. Find the solutions to the quadratic y equals 8x squared plus 2x minus 15. The first step is to draw out a big X like this, right below the equation. The left side corresponds with the a value, while the right side corresponds with the c value. So on the left two ends, we come up with two numbers that multiply to get to our a value. In this case, our a is 8, so let's try 4 on the top and 2 on the bottom. On the other side, we have to think of two numbers that multiply to get us negative 15, which is the c. Let's try negative 5 on the top and positive 3 on the bottom. The next step is to multiply the numbers on the diagonal and add them up. 4 times 3 is 12, and negative 5 times 2 is negative 10. When we add these two numbers up, we get positive 2. If these are the right numbers, the sum that we get will match the b value in our quadratic. Since our b term is also positive 2, we know that we've got the right numbers. Although you could have very easily chosen different numbers, so if your numbers don't match up on your first try, don't worry. If you end up with the same number but the opposite sign, you'll just have to swap the negative sign on the right. If you end up with a totally different number than your b value, then you'll have to come up with different factors that still multiply to get your a and c values. This might seem like a long process, but with practice, it gets easier. The next step is to simply put an x beside each number on the left. They become our coefficients. So our 4 will become 4x, and our 2 will become 2x. Our numbers on the right become our constants. Last, we simply group them up like so, giving us a factored form of 4x minus 5 times 2x plus 3. All that's left is setting them equal to 0 and solving for x, which gives us x equals 5 over 4 and x equals negative 3 over 2. The form y equals a times x minus h squared plus k is called vertex form. This form makes finding the vertex very easy. The x value is simply the opposite of what h looks like, and the y value is k. For example, in the equation y equals x minus 3 squared plus 2, h appears to be negative 3, so the x value of the vertex is positive 3. And k is positive 2, so the y value will be positive 2. We only flip the sign for the x value. Completing the square is mainly tested in two different areas: circle equations and quadratics. This video will focus on the quadratic portion. Sometimes you may be given a quadratic in standard form, and they'll ask you to convert it to vertex form, like in this question. The first step is to find your coefficient of x. In our problem, our coefficient is 4. The next step is to take half of that number. Half of 4 is 2. This number is important in later steps, so I like to just write it off to the side and box it. The third step is to square that number and add it to both sides of the equation. 2 squared is 4, so we'll add 4 on both sides like so. I like to circle what we add to make sure that we do it on both sides. Now we focus on the quadratic that we've just created by doing this, ignoring that 3 for now. This is where that 2 that we boxed earlier comes in handy. You could factor this quadratic out, but a trick that can save you time is that this quadratic will always factor into x plus whatever number that we boxed in the beginning squared. So always keep track of that number. And if you forget to write it down, it's simply half of what our coefficient of x was. Also note that it could be negative 2 if our coefficient of x is negative. So now, when we apply this trick, we end up with x plus 2 squared plus 3. The last step is getting all our numbers on one side. So to do that, we can subtract 4 on both sides, which will give us y equals x plus 2 squared minus 1. Our vertex is then the opposite of what h looks like, which in this question it looks like h is 2, so the x value of the vertex will be negative 2. The y value of the vertex is just k, which in this case is negative 1. So the vertex is negative 2, negative 1. Let's look at some practice problems. Which statement is false about the quadratic equation above? This question is testing us on our knowledge of maximum values, the direction of a quadratic, y-intercepts, and the axis of symmetry. But the good thing is, it's a true-false question, so the best strategy for this is to start with whichever option is easiest to solve for. Choice D states that the y-intercept is negative 5. And since it's pretty easy to find the y-intercept, let's start with this option. To find the y-intercept, all we have to do is set x equal to 0 and solve for y. 0 plus 8 gives us 8, and 8 squared will give us 64. Then, when we multiply by negative 2, we get negative 128. Minus the 5 will give us negative 133. So choice D is clearly false. You could simply circle this answer and move on, but for teaching purposes, I'll go over the rest of the choices too. Choice A states that the maximum of the quadratic is negative 8, negative 5. But what are maximums and minimums in the first place? Well, you already know that every quadratic has a vertex. That vertex can be located at a peak or a valley. To determine which one it is, we pay attention to the sign of A. Since our quadratic is in vertex form, A is negative 2. Because it's negative, our quadratic opens downwards, like a frown. Therefore, the vertex will be at the peak, which means it's also a maximum value of the quadratic. Now let's find the vertex. Remember, our x value of the vertex will always be the opposite of what h looks like. In this case, it looks like positive 8, so we know the x value will be negative 8. And the y value is just k, which is negative 5. Therefore, choice A is correct, since negative 8, negative 5 is the correct vertex, and it's also the maximum value of the quadratic, since it occurs at the peak. Choice B states that the quadratic is concave down, which is just a fancy term for opens downward. Whenever you see something unfamiliar like this, don't be afraid or overwhelmed, because you might still be able to answer the question just like how we did. Simply stick with what you know and look for ways to apply it. Since A is negative, we know that the quadratic opens downward, so this choice is also true. Choice C states that the axis of symmetry is the line x equals negative 8. The axis of symmetry is another fancy term for the x value of the vertex. Because if we were to draw a vertical line right on the x value of the vertex, it would split the quadratic perfectly in half, which is why it's called the axis of symmetry. And since we know that the vertex is negative 8, negative 5, the x value is indeed negative 8, which makes the statement true as well. So the correct answer must be choice D.